Fresh, stale, and historic talks about the relative freshness of data and how variable that data can be. So fresh state is just generated, looked up, or learned. You assume it to be an accurate current representation of the described variant, object, or circumstance. Stale object is the same kind of data, but it's already a little older. You have held onto it for a longer period of time, and now there's some risk that that data may be out of date. And in fact, in most systems, if you have variable data, if the data itself that you're holding onto can indeed change, then as soon as you have looked up some data from a data store, there is some risk that that data may be stale. So what you need to make decisions about in your architecture is how much staleness you can tolerate in your system, and that is often directly dependent on what kind of business scenarios you want to support. So let's say you are storing a customer shipping address in your system. You have to ask yourself how and whether you can go and tolerate that shipping address to be used when the customer has just updated their address. And the answer there is you often have a tolerance of multiple days for this, because you can go and still send data. You can still send a mail or a package to the old address, because there will be compensation in place by ways of the postal system or your package carrier that will be able to forward that piece of mail to the new shipping address, because presumably the customers have done this, or alternatively the package will be returned to you, and by then you can take on that correction. So very often it's okay to operate on somewhat stale state. When the state is invariant, when the state cannot change, you can have a completely different strategy by just dealing with historic state. And some systems designs are actually going completely on this route, where they don't allow any variable state in the system. They don't allow any deletes or any updates inside of their data store at all, but keep every data that has ever been inserted in their system. And instead of creating records that can be changed, keep chronologies of data around. So for your customer shipping address, instead of updating the record, what those systems will do is they have a validity period, valid from and valid to, around that record. And as a change is applied to the customer shipping address, instead of updating that data, they will insert a new record, will mark the old one as invalid from this point on, and then the new record will be valid from today on until the future. The advantage of having systems that are built in chronologies, that are keeping historic data and never update, is that they're very easy to handle in terms of replication, because once replicated state can stay replicated. You don't have to ever update that state, because it will never change, and all changes into the core state of the system are additive, and also all replications are additive. You're simply adding additional messages. The current view on a historic system is that you create views over your data, which always take into account the current date, with which you then can go and query all the related records and select those which are in the current validity period. Another advantage of using that mechanism is you can rewind your system to any point in time and get the appropriate records for the appropriate point in time when a certain legal event happened, for instance.